Do you seriously think, do you literally think, that there are two people exactly like us with our dreams, our thoughts, and in some other stage right now, or whatever you'd call now, over and over again right now, all over the universe? Or do you just say that?
Well, there's a key element that we have been assuming, and we've been assuming that the universe is infinitely big. And we don't know that the universe is infinitely big. It could be that you go on for some distance, and you walk and you walk, and you wind up coming back from that direction, sort of like the surface of the Earth. It has a certain size, it's not infinitely big. It doesn't have an edge, you can't fall off, but nevertheless, when you keep on going, you return to your starting point. It could be that the universe has that kind of a shape. However, the other possibility is simply that it goes on forever. And we don't know which is right. The simplest one mathematically is that it simply goes on forever. And if that's the shape of the universe, then yes, I fully believe that we are out there in some notion of now having this conversation not once, not twice, infinitely many times.
Well, aside from the deep creepiness, well, let's talk about the creepiness of that. I mean, there is a notion that we all have that we are unique individuals and that there is a real version of us. In my case, you're looking at him. So
you just said that 1,000,000 billion times over in the other universes. There are a variety of bubble universes. Ours is just one. When we study the cosmological data, it leads us almost inexorably to this picture where there are more than one bubble. And these bubble universes are not talking to one another. They are not touching each other. You can't reach the other bubble. You can't traverse the space in between in a meaningful way. Yeah, the way I like to think about it is this picture, this inflationary picture. It's as if the universe is a big block of Swiss cheese. And I'll just stop right there. Thank you. No, it's like a big block of Swiss cheese where the holes are the universes that we're talking about. So everything that we know about is one hole in the cosmic Swiss cheese, but there are many other holes in the cosmic Swiss cheese. And the point is, when we study this picture that emerges from studying the cosmological data, not from an overworked imagination, we find that the meaty part of the cheese, the white part of the cheese, expands so quickly that the bubbles, the holes in the cheese, are pushed apart at an enormously fast rate, faster than the speed of light, and that's what prevents one from, even in principle, going from one hole, one bubble, our universe, to another hole, another bubble. So our universe and the other universes are all embedded in this environment, this cosmic Swiss cheese, but we can't traverse the cheesy part because it's growing so enormously quickly.
But, oh dear. See, now, this is your cheese hole now.
Yes.
Okay. So I'm living in there, and my universe is getting bigger and bigger. So this Swiss cheese has a hole that is growing.
The hole is growing larger.
The hole is growing. And you're saying that the cheese...
But the right part of the cheese is also growing, and it's growing faster than the rate of which that hole is growing. So there's bigger holes, but more cheese.
So the reason I can't talk to you, if you're in your hole and I'm in mine, is I'm here growing, you're over there growing, but the space between us, we would be flying to either side of this stage.
Yes.
Faster than the speed of light, you say?
Yes, faster than the speed of light. Sometimes people say, well, how's that possible? Nothing goes faster than the speed of light. And the thing to remember is that when Einstein established that nothing goes faster than the speed of light, what he really established is that nothing can traverse space at a speed greater than the speed of light, but his equations full well allow space itself to grow at any speed. Bigger than the speed of light is perfectly fine.
Okay, I'm going to have to keep summing up because otherwise I'm going to get completely lost. So, the universe then is a series of expanding empty spaces inside a web of some kind. What I don't still understand is, where did these holes come from? In Swiss cheese, I have no idea where those holes come from either. I consider this the dual hole problem myself.
in the beginning, whatever that means, space is filled with something that we call a field. An inflaton field is the name of it. And a field is very much like an electromagnetic field. I think we're all pretty much familiar with that idea that there are electromagnetic waves going through this room. That's how you can use your cell phone to talk to somebody far away. The electromagnetic waves are suffusing space. Those electromagnetic waves are fields, electromagnetic fields. This inflationary theory invokes a new field, not the electromagnetic field, that fills all of space. And it has the amazing property that by virtue of filling space, it causes space to be filled with repulsive gravity. That's what this field does. Repulsive gravity pushes everything apart. And in this environment of this field filling space, gravity is repulsive, drives space apart. As space is driven apart, it turns out that there are regions where this field drops to zero value. It quantum fluctuates to zero value, and those are the holes. And let me just quickly say, as it drops to zero, it gives up its energy to the familiar particles that make up you and me in the world. So all the particles that we know about in this version of cosmology come from this field dropping down to zero, releasing its energy to particles that give rise to the stuff that we are familiar with. Now that field can drop to zero all over the place, giving rise to a bubble universe here, a bubble universe there, a bubble universe there. But in between, the field still has a finite value driving space to expand.
So sometimes you get an explosion of nothing, which then melts down into us, and sometimes you don't get very much at all. So and there's this sort of thing underneath everything that's doing it.
As long as by thing underneath everything, you mean the region of the universe in which this field has a repulsive gravity effect and drives space to expand.
What we end up with then is very distinctly different neighborhoods. Each of these bubbles can have its own character.
So there are a number of kinds of infinities that now come into the story. Number one, you can ask, how many different bubbles are there? How many different holes in the cosmic Swiss cheese are there? And indeed, this is a process that we believe to be eternal, and therefore there would actually be an infinite number of these little bubbles, with our bubble being just one. And now you might say, but wait a second, you started off this conversation talking about space that we have access to going on infinitely far. If our universe is a bubble, no matter how big, it doesn't go on infinitely far. It has some size to it. To someone on the outside, it looks like this bubble has finite size. To anybody on the inside, it looks like it has infinite size. This is a very minimal approach to describing observations that we have. Observations of the cosmic microwave background radiation, observations of the early universe by looking deeply into space, can only be understood, largely speaking, in the context of the frameworks that we're discussing here.